Let's go to Liquid 3255, find the power of K-size subarray 2. It gives us an integer array nums in the integer K. We want to return an array with size n minus K plus 1. So result I should be the power of this kind of nums from I to I plus K minus 1. So what does this one, the power mean? The power is its maximal element in all of its elements that are consecutive and sorted in ascending order. And if it's not in ascending order, um, return minus one. So, for example, if this is size k, right? So this one, we'll say this is consecutive and also in ascending one. So the next one will be the last one. So will be three, right? And also let's move this on to the next window. That is two, three, four. It's also ascending and consecutive. So that will be four, right? And then that is three, four, three. It's not a consecutive, so it will be minus one. And also let's look at the other windows like until three to five. It's not a consecutive increasing. It's minus one. Right? So let's return this kind of arrays, right? So what we're thinking about is that we just use group iterations, and then when we just count the consecutive increasing um, counts, right? So if the count is already greater than k, then we can update the I minus k plus one, right? For every index one, and also the current one, I it is the maximal value, right? So let's write code for this. Um, so we're going to have int n equals nums dot length, and we'll have count equals to zero. So this count means the consecutive and arrays counts. How many elements subarray, which is already consecutive increasing order. So what we do is that we're going to have int result equals new int. So as we talked about, it will be n minus k plus one, right? So what we do is let's set this one as array fill result minus one, right? So that we if we it's we just have a condition if the count is not greater equal to k, we'll not update. If it's greater equal to k, we are going to update. So what we do is for int I equals to zero, I smaller than n, I plus plus, right? And we'll have count should increase by one, means the consecutive increasing one, right? So I write if count is greater equal to k, and I should greater equal to k minus one, right? Mm, so actually, we don't need I greater equal to um, k minus one, right? Because this condition will guarantee this I should greater equal to k minus one, right? So we can have result I minus k plus one equals nums I, right? So then we do group condition if I equals n, when should we set the group or nums I doesn't equal to nums I minus plus one minus one, right? Then we'll set the count equals to zero, reset the count. So in the end, just return result. It is ON time complexity and ON space complexity. Let's also write a Python code for this. So we are going to have n in the count equals length of nums, and this count equals to 0. So we have result equals um, this one minus 1, right? For multiplied by n minus k plus 1. So what they do is the for I in branch, and then we're going to have count should plus equal to 1. And if a count should greater equal to k, then we're going to have a result I minus k plus 1 should equals to nums. And when should we finish the group iteration? Reset, if we go to a new group, that is if I equals n minus 1, right? Means we end of this group or nums I done equal to nums I plus 1 minus 1, right? Then we'll have count reset at 0. In the end, just return result.